objective. We're going to talk a bit about AI and cybersecurity, again, from a layperson's perspective. By the way, anyone here take some courses in AI and machine learning? Few of you, good. If I make mistakes, you can correct me. We're going to talk about how we approach a problem, how we reverse engineer the product and the results, obviously, and then a bit about the publication and the feedback, which was significantly more louder than we thought it would be. All right, so let's start with the why. Why would we even want to look at a new endpoint protection product that claims to have solved security and check how it fares against a bit of onslaught? So first thing, and I hope many of you can relate, is challenge, right? It's just interesting. Let's try and see if we can bypass that. The second thing is to assess technology, and I think anyone in the security community, we try to help other people understand what works, what doesn't work, what is effective and what isn't. And to do so, you have to be able to use your hands, look at projects, understand what they're really worth, and if an adversary is capable of bypassing them. Finally, this is a personal favorite for me. Every time I see a silver bullet, someone explaining, usually it's a salesperson, way too much gel on their hair, explaining to the company that if they only buy their product, they will be 100% secure and no hacker will ever be able to hack them. This is a very sad reality of the history, and it happens all the time. So why Cylance specifically? And I'll kind of a bit of a spoiler. This thing went very viral, and we got lots of questions from reporters. And there were some, I saw in forums, people were writing that this was a hit piece, that we were paid by competitors to show that the Cylance's product is inferior. I don't think it's inferior. We selected this for, I'd say, rather mundane reasons. One, you can get it really. It's easy, just go online and buy it. A lot of companies protect their products by just not allowing you to buy them and research them, which is kind of sad when you think about it. Cylance put AI front and center. They're one of the first companies that said, AI is the thing. You don't need anything else. This will solve this problem with malware, and that's really why we focused on that. It had nothing to do with obviously anyone paying us to do so. Now there's a few quotes here. This is actually from the website, right? So when we're talking about a silver bullet, we literally use that. So the product is as close as you can get to a silver bullet. Or things like Cylance provides 251% return on investment. What does that mean? What does it mean? Right, so all of these things kind of didn't help and kind of helped focus us on this specific product. Now, what are we actually aiming to achieve? Has any one of you ever tried to bypass a security control as part of your work? Cool. Anyone else? Two of you? Samir. All right, cool. So I'll put it this way. Being able to bypass an endpoint protection product, or let's say you have this one malicious file you want to execute, that's really easy. That's entry level, right? You all have to do it. I expect you to be successful at that. The challenge we had, we wanted to create a universal passive bypass, which is a term we completely invented. But what it means is that we don't want to work hard every time we have a new malicious file we want to use to bypass the security. And we want it to be passive in the sense that we don't want to attack the product itself. We want to understand how it works and then fool it passively with whatever method we know. Right, so this was our main objective. And obviously another thing I wanted to say here is that the fact that you're using now machine learning as a protection mechanism also means that you're exposing a new attack surface, which is the machine learning model itself. This was kind of a secondary objective. So I'll need a volunteer, not you, Samir. Someone? Come on, someone. All right, thank you. What is that? Amazing. The fact that you were able to answer that is because you have an amazing brain, and you have this capability to classify objects, right? It's not trivial that you were able to say this is a cat, and I'm pretty sure you didn't spend many years studying cats to be able to answer this very simple question. Do you know what breed this is? No. And you are also capable of saying this is a cat, although it's a really funky cat. It has shampoo in its hair and it's wet. So I've kind of meddled a bit with its features, but you're still able to do that because you have a bit of resilience around your classification model. And that is kind of in a nutshell classification of problems in AI and machine learning. You're given an object, you have to say, for example, here's a picture, is this a cat or a dog? And you have to produce an answer. Human beings are amazingly good at that. There's a whole field of research that kind of deals with how to do this artificially. Okay. Now there's a similar thought process that came into mind of several people in this industry, and they said, why don't we do the same thing to understand if what we're looking at is something malicious, like a malicious file, or benign. That is kind of how this whole field of AI in endpoint protection at least was born. It makes perfect sense when you think about it intuitively. Now there are two main streams of work, I would say, when you're trying to build something like this, especially if you're trying to do this in a commercial product. The first thing is you have to build a brain, right? This is the really, really hard part. This is where you have all your experts, you invest all your money, and we'll go through the process. And then the second thing is the actual classification itself. So I'm going to assume that your parents spent a considerable amount of time training you to identify cats. Hey, everywhere I put you, you go like cat, dog, definitely 251% ROI, right? On that investment. So in the training, what you want to have is a very large data set, lots of pictures of cats and dogs, or for example, lots of malicious files, lots of benign files. You need to have all the data to be able to understand almost intuitively what is what. You need to select what features you're focusing on, and this is really key. So when you're trying to understand if something is a cat or a dog, intuitively, you're looking at all kinds of features, right? Does it have the whiskers? Does it act like a douchebag? All kinds of things that you intuitively understand, and this is something that has to be done in the feature selection process. All right, so just to give you an example of something that is meaningful versus something that is not meaningful, if this animal in the picture has fur, probably not meaningful to decide whether this is a cat or a dog. But if it's a douchebag, super meaningful, super useful. So you have to decide on the features you're using, and then there'll be the phase of training. There are multiple ways to do that. There's, like I said, a full domain of knowledge around that. I'm not going to get into that because I'm not an expert, like I said, but this is that magic. And what's important to understand that at the end of this training process, you have a model. The model is a mathematical function, kind of simulates our brain. I give it an image, for example, it tells me cat or dog. I give it a file, malicious or benign. This brain gets deployed to all those endpoint protection products, millions of computers, and then all that money invested in the training is really used to classify hundreds of thousands of files as they're being used on your endpoint. There is one, for me at least, when I heard about this concept, was a few years ago. There was one conceptual issue, one conceptual problem with how they approach this whole problem classification. And the thing to me is, a cat is fine with being a cat. A dog is really fine with being a dog. They're not trying to be something else. So the whole concept of being a malicious actor does not exist in the approach of these products. Right? They're saying, okay, the file will be what it is, and then I'll classify it. But that's not necessarily how threat actors work. Once you've introduced the security control, as a threat actor, I can come in and say, all right, how do I make myself look benign? What are they looking for? If to use an example from different domain, for example, this dude here, right? Let's say I told you that I want you to fool a classification model that tries to classify between human beings and chickens, in this case, right? You could then wear a very stupid costume that costs you $5, and then maybe you would be able to fool that model because kind of innately, they're not trained to identify when someone is trying to fool, right? And this is kind of our thought process when we're trying to think how to approach this whole problem. Any questions so far? All good? Cool. So I think it's an intuitive thing for a lot of people in this field want to do this research, they want to fire up their technical tools, start reverse engineering, jumping into the code, trying to understand what it does. Huge mistake, right? That's not where you should start. The first thing you should take advantage of is what I call the OPSEC paradox. OPSEC stands for operational security. In other words, how well does a company protect its own secrets? If you are the CEO of Cylance, it's bad business for you, for other people to know how your product works. and be able to bypass that and then publish this type of annoying research, right? It's bad for your business, okay? So you would think that they would be protecting their secrets. But what's actually happening, the real forces behind these commercial entities, and they are commercial entities first and foremost, are the productivity, you have marketing, you have legal, you have the commercial forces behind it. And all they want to do all day long is talk about the product and explain how it works, explain why it's so superior, why it's great, why you have to use it. And they do so through patents, and they do so through white papers and booklets and conferences. And the amount of information as a security researcher you can get just from that open source intelligence, aka OSINT, is just mind-blowing, all right? Mind-blowing. So the same company that could claim to be protecting other companies is usually not that great at protecting its own secrets. But there are a few tools you can use, and we've definitely used all of the tools listed here. Patents is, to me, kind of a personal favorite. And the reason is it's super boring. It's written legal, legal terms, etc. But it really gets into the mindset of the chief scientist and founders. This is what we did. This is the process. This is how we look at a new file. All of that stuff is going to be publicly available because that's how patents work, right? All of that's going to be out there. You have white papers and books, like I said. YouTube is a great research tool. Tons of conferences you can find where they explain how the product works. So there's I think a pretty cool example here. So this is basically just a folder where you have the files of the product. And this is an excerpt from one of their white papers. So the first thing they tell us is what the actual model is called, like how the product itself is called. And it's called Cylance Infinity. They always have these type of strong, powerful names. And when you look at the actual files, there's something called Cylance Post Infinity Model.dll. Does anyone want to make a crazy guess what we can find in the Infinity model? Anyone? The model, right? Right? This is probably where you can find the model. They're also telling us that they have different types of classifiers for different types of files. Lo and behold, there's a file called sample scoring 2 PE. Does anyone know what PE stands for? Yeah? Yeah, portable executable, right? So it's not privileged installation, it's portable executable, and my educated guess at this point was this is probably what gives score to an executable, right? So I have a file that's probably the model. I have another file that tells me that it's going to give me a score for a file. It's a good start. There's tons of more information that I'm not going to show here that was extracted. All right. We have a good starting point. So I don't know how many of you tried to reverse a .NET assembly. It's significantly easier than reversing anything else in the world. So we're looking at the Infinity model. It has a few resources. One of them is called Infinity model, which I'm guessing is the model. And we have actually one of the interfaces, the key to decrypt this super protected model. And the key is I'm decrypting silences the actual file. That is actually, all right. I think the reason they did that is because I think it's a warning sign of some sort. I think they're telling me something. I'm not sure they want us to actually decrypt that. But what I actually want to do is use the key, decrypt the model, and start poking around the model. This is an infinite idea, and thanks to my partner, I didn't do it. He told me that straight away, and he was right, because what are you going to see? The model is a collection of numbers. There's nothing to actually deduce of it. It's a number. Won't tell you anything. Unfortunately, this probably saved me about 2 weeks of worthless work, and we did something a bit different. And what we did is, again, this is super convenient when you're using .NET assemblies. We said to ourselves, hang on, we actually have all the libraries. Cylance have given us all their libraries. They've given us the names of the libraries. They've given us the interfaces and the functionalities. We can build our classifier using their stuff. So we wrote this engineering masterpiece of 5 lines of code. And what these 5 lines of code enables us is a starting point for dynamic debugging. So basically all this does is you basically put in a file, whatever file you want, and it will give you the score. And it will use the existing libraries in the model that they're using. So they will do the decrypting and all the hard work, and we will be able to step into the code and see exactly how it works, right? Way easier than looking at it. Now they had a couple of mechanisms that are built in to stop us. One is useless, and the other one is annoying. I'll start with the useless one. There's a property for document assembly which is called suppress DASM. If it's set to like 1 true, basically you're getting this really scary error message. Does anyone know this property? Have to work around that? No? So the cool thing about this property is that it's based on honor. You don't have to honor it. All right. So some disassemblers honor it, some just ignore it. And even those that honor it, you can just change the property. It's false, and there you go. You're done. So that is the user's protection, because I really don't know anyone about that. And then they have the obfuscation mechanism where they have go-tos and they mangle the names, and nothing means nothing is human readable. But if you have dynamic debugging, you're capable of stepping through the code. Not that bad. Not great, but not that bad. All right, so now we're at the point where we can start actually doing the work, right? Heavy lifting, understanding what the hell is going on. How does this thing work? And the first main mechanism we're seeing is really a parser. So you throw in an executable, it gets parsed, and we have all these different properties that the parser is looking for. Many different types of properties. They're not features yet. These are properties. Talk about it. And there's a kind of a one-to-many relationship between properties and the amount of values. Some of them is just one. Strings, for example, more than one. Depends. We have no understanding at this point what this actually means and how it works. This is the harder part, I think. So at this point, what we're seeing is that there is some kind of conversion from the properties that are parsed into that feature vector, right? The feature vector is basically, just to explain from what we've seen before, that would be the equivalent to saying, has fur, acts like a douchebag, number of legs, all that stuff that we'll need to make that decision if that thing is a dog or a cat, right? So this is the process where they're taking properties of the file and they're actually creating that into features. And what we're seeing is a table of tables. This was really hard to understand, but we realized that for every property type, for example, we saw a CLR before, jump to the next slide. For each property type, there's a handler, and the handler is a table that basically says, if the property is of value, for example, 1, do these increments and decrements. If the value is 1 for 1, do that. So there's a different list, kind of if then else, or switch. It tells the software what to do for every type, for every value of that type. And what it actually does is it looks at this array of 7,000 elements, which is the feature vector, and increments and decrements all kinds of items in that. So again, I know this part is a bit hard. You extracted a property, you go to the property handler, you check the value, you go to the right row of that value, and you start doing increments and decrements in the feature vector. This process is repeated for every value, hundreds of thousands of times. At this point, we also understand that the feature vector is not going to be human readable for us. We're not going to be able to look at the feature vector and go, oh, they look at only 1 or 2. They're intricate relationships between the different properties in the file. So we're not super optimistic at this phase. Not to mention this phase. So,
oh man.
yeah. So actually, I presented this in B-sides in Sydney, the first and the last B-sides in Sydney. And I asked if there were any students in the crowd, so I don't think I have to ask that question this time. How many of you thought you're going to actually be using matrix multiplication in real world research? How many of you said, I'll never need this matrix multiplication? I said that, I'm sure. So I'll explain. So we had a feature vector at that point. We were like, okay, there's no further processing on the feature vector. It's done, like the values are set. But we're still seeing tons of calculations afterwards. Something that leads to the score. And we took basically a piece of paper and pen and we started, all right, multiplying this, adding that, multiplying this again, adding columns to rows. At one point we're like, that's just multiplication, really? And you Google that a bit, like I said, we are not experts in the field, and we realize there's a good chance that that's what we're seeing. That is indeed what we saw. We also saw that every element, when you do this simplification, there's the hyperbolic tangent function. And I know I sound smart when I say that. And that is applied to every element in the metrics. And again, a bit of research, we didn't know what that is being used for. We realized that this is really an approximation of a neural network, which is one way to implement this type of classifier. All right. Again, I'm not an expert at that. If I'm wrong, maybe, but this is what we saw for sure. And we actually constructed this function. No one gave us this function, but this is basically what we understood that we're seeing. Now, the A's and the B's and the C's are constants. And these constants are actually the result of that training that Cylance did in their lab. Right? This is their IP. And this is something we've never released and will never release because, it's theirs. And we understand at this point that we have kind of the model core and we understand, so to speak, from a mathematical perspective, how do you get to a score? So this was probably the first time in high five. There were a few times after that. So apparently we're not done yet. So you have a score at this point. It's between -1 and -1, -1 being super malicious, 1 being your best friend, right? But then we're seeing that there's actually an additional mechanism after the scoring is given that can bypass the score that was given. And this mechanism is a white or blacklisting mechanism. I mean, both white and blacklisting mechanism, but it's not really straightforward. It's kind of complex and sophisticated. So it's not that they're saying, the file is called X or Y, or if the hash is this or that, change the score. What they're actually doing is they're reducing the feature vector to about 3,000 elements. And for the sake of example, let's say that they're reducing to 3 elements, and then it's a pointed space. And they're saying, I know about, let's say it's a planet, right? And they say, I know 20 good planets. And if you're close to one of the good planets, you're a good planet. I know also about 30 bad planets. If you're close to any of those planets in space, you're definitely a bad planet. So they can completely switch the decision. Anyone wants to hypothesize why they would have this type of mechanism? Don't be shy, you can say something stupid. I won't laugh. Well, maybe I will. Yeah.
There'll be some similarities between malicious and good. To account for that, they would just go based on heuristic of how other samples work. Try to work with that.
Something like that. I think I would call it a compensating mechanism. All right, probably some sort of. So again, I don't know. I really don't know. I don't know to this day because we didn't have this conversation with Cylance. They only asked us for our samples and a bit of our research, and then they basically unfriended us. But my guess, and this again, this was part of our thought process. This is not a something we thought of after the research. In our thought process, we and we have lots of industry experience and like real world experience, and we try to get into the heads of the engineers. And this is again very, very important when you're doing something like this. Is not only stay at the technical level all the time. Think of what they're thinking. And we said also, what's probably happened is that they had this, amazing idea and this really optimistic concept that they'll have the model and the model will be 100% correct. Obviously, it doesn't work like that in real life. And they probably had false positives and false negatives when they started deploying this in real world networks. That's usually what happens. And this to me seems like maybe a combination of a hotfix mechanism, right? They put it out, it had some false positives. It's disastrous to have false positives and start quarantining, legitimate files. And someone was called in the middle of the night and had to come up with a mechanism to solve this. This is one thing, like a hotfix, probably. And the second thing, maybe close to what you said, maybe the model is not that accurate, and they had to somehow take care of those outliers that didn't match the original model. One way or another, definitely they have this mechanism. It can actually take a file and change completely the decision on that file. So we're looking at the the whitelisting and the blacklisting mechanism. We have a list. Again, this is related to their operational security. These strings were read them. And at one point, and I've been a lifelong gamer, I'm seeing something called Rocket League. Like Rocket League. Sounds like a game. So, embarrassed to say I didn't know this game beforehand, but I Googled that, and apparently some people like playing soccer with cars. It's a thing. And we started thinking, why would they have this, specifically this game in their whitelist? What could be so different about a game that they had to go back and do something different with that? So hold that thought, we'll talk about that. So at this point, we have basically two options, right? As researchers, we can attack the whitelisting mechanism, so we can try to get you close to a good planet, hopefully. Very hard. We thought about it for about 2 minutes, and we're like, don't want to start there. The second option is to attack the core mechanism, right? We need to search maybe for properties we can influence easily. Like we know they're looking at the different properties, and that's what builds the feature vector. So if only we could find one type of property that is potentially has some kind of bias or an opportunity to influence significantly the feature vector. Fortunately, there's strings, right? And when we're looking at the different types of property handlers, we see that most of them have there's the size of the handler, right? So most of them would have, for example, 3 possible values, 4 possible values. So at most you will have maybe 4 of that in the file. But strings have 854,069 different values. So Cylance selected, I don't know manually or automatically, but selected this number of strings that could potentially influence the feature vector. And to us, it kind of opened our eyes and we're like, okay, we can play, all right? There's a way potentially to influence the feature vector with that amount of strings. Just to explain again how it works, I know it's spoke about this about 20 minutes ago. So when you parse the file, you get a string, you hash the string, you compare it to a list of 854,000 existing hashes. If you get a match, you influence the feature vector, right? You make some change to your decision about the file. So the hypothesis of this phase. So we understand this is not, the first part is not really an hypothesis. We understand the strings have the potential to have disproportionate impact on the feature vector and therefore on the decision. So we definitely want to do something with those strings. We know we can do something, but what exactly do we want to do? So we have this hint from the whitelist of what potentially executables are considered good, specifically Rocket League. And now if we're again getting into the minds of the engineers, what would you do if you had this issue with Rocket League and you had to do this hotfix? The next thing you'll probably do, go back to the lab, try to retrain your model and make sure it doesn't happen again. You don't have to do a hotfix for every game out there. And we start looking also at games and we try to look at what's so special about them. And we realize that there's a good likelihood that the type of strings you would find in games, you're not going to find in Malware. You're not going to have strings that are about lobby, fragging, and pound, and all kinds of things like that in Malware, probably ever. So there's a very good chance that these type of features will have a strong impact on the decision. So if we strip the strings from a game like Rocket League, and we basically carefully inject them into any file, maybe it will look like Rocket League. Maybe it will have such a big influence on that file that the brain will look at that and go like, oh, that's definitely a cat, right? So let's have a look. Oh, before I look. So I said carefully inject. I was lying, lazy. We just slapped the strings at the end of the file, right? We wanted to do it carefully. We didn't feel like it. So we really just concatenated strings together. And what we basically we didn't optimize anything. We just took the strings from Rocket League. We stripped just to make it lighter weight. We stripped away any string that wasn't in that hash table. We hashed the strings and made sure that they're actually referenced by Cylance. And then we were left with about 60 kilobytes of file. And then we said, all right, that's right, but what can happen, right? It won't work. Definitely not on the first try. All right. Where's the cursor? See it? Yeah. All right. Cool. So what we're doing first is we're actually throwing 3 files that are known to be malicious. One is Mimikatz, credential harvesting software, and 2 other ransomware, including the OG one. So well-known bad files. As you can see, well, resolution is bad, but Cylance detects those files and quarantines them immediately. What we're doing now is we're basically concatenating the strings in the most rudimentary way to these three different types of malicious files. And when this research was peer-reviewed, a lot of people told us, this is maybe going to work for static analysis, but once you actually execute the files, definitely the dynamic engine will be on to you, like you're doing really, really bad stuff. So what we decided to do is to run Media-Cats, and then run Samsung, which is a ransomware, and then run WannaCry all at the same time, all right? Which is what's happening right now. You'll start seeing things getting encrypted, and there they are, and really nothing, not even a whisper from Cylance, all right? And this was kind of the first thing we tried. We were very, very lucky in that sense. So this virtual machine is big encrypted in this demo, right? Dynamic behavior analysis friendly. So now we have to be responsible adults and look beyond the three samples that we have, right? So we start by looking at the Center for Internet Security top-rated malware, right? And they have a monthly list of the 10 worst malware for that month, okay? So that's the table on the left-hand side. As you can see, they detected only 9 out of 10. We had nothing to do with that. Not a thing. But on the right-hand side, you can see the score after we just slapped those silly space. It's the only thing with it, nothing more sophisticated, right? And I think the important thing is the scale of the change, right? If you look at push code, it goes from -999, which is the worst, to 999. And that is what you see on most of them. The change is just immense. And then we said, all right, maybe that's another fluke. Let's go for a larger sample. And we went to something that's called Zoo. It's available on GitHub, 384 samples. We didn't get 100%, unfortunately. We got only 88.54, but this was before any optimization on our work, and it can be optimized significantly. And still, the average change in score out of a range of 2 is 1.67. All right? It's as close to universal passive bypass as you can get. So now we're definitely high-five. So, again, like I said, this was not even a really planned research, but we thought we had something cool at this point. And I reached out to Kim Secker, if you've ever heard of her, but she's a very, very prominent journalist in cybersecurity. She worked for Wired, Vice, etc. She was really, really interested in our research, and this thing really exploded. It started with Vice headline, Vice for a few days. Then went to the Washington Post and pretty much every security publication out there. The response from Cylance was really funny. Really the classic, right? It's actually not a real bypass. It's just one component of the one component. Yeah, right. And they said they're gonna send a really quick fix, and they had this long list of things they're gonna fix over the weekend. And this is just my guess about what happened. They claimed to have made the fixes in the enterprise version, which we had no access to, but they never, at least we checked this a few months ago. This is a year and a half old, right? We checked this a few months ago. They still haven't fixed this for the home version. Right? Again, my hypothesis, they don't want people to have access to the latest technology. Maybe who are not enterprise customers. Maybe. That's just my hypothesis. We got tons of questions being asked, and we had lots of endpoint protection companies come to us and say, would this work on our product? And can we check this and all kinds of things like that? So it was really fascinating to see the type of response, and I think that we've seen lots of response also in academia. There's people literally using our stupid blog posts on their serious PhD thesis when they're talking about attacking AI. And I think the funniest phone call I got was from someone in a venture capital firm, and he was telling me that he kept hearing our name from companies that were pitching to them that you now need security products to secure machine learning models because of the research that we have shown. So there's been way more, commentary, I'd say, than we thought, and I at least was very happy that this turned out like that. Questions? Yeah, who wants to start?
Oh,
He's
okay.
vice president.
Hello, hello. I might have missed this at the very beginning, but like, did you ask,
Absolutely.
was it Cylance? Was that before you hacked them, or did you hack them and then tell them at a product flaw?
You know the saying, it's better to say that you're sorry than to ask for permission. So it's actually a very good question. I'd expand on your question and ask about the relationship between security researchers and product companies, right? So it really depends. And no, we didn't get their approval, and we probably would never get their approval because it's a different approach from different companies. There are companies who, after this research, came to us and said, "We'll set up a lab for you. Do your worst, right? And show us what you can, right?" Some have this response. Other companies are, you know, if you ever go near our product, we'll sue you. But just so you know, in Australia, you can really reverse engineer whatever you want. Not a lawyer, consult with a lawyer, but generally speaking, the law is very permissive here when it comes to reverse engineering, right? So we didn't ask for permission, and honestly, we wanted to help them way more. After we released this, they just asked for the strings and just asked a couple more questions. Like I said, then they have threatened us. Basically, they didn't want to talk to us. Anyway.
Were you ever asked to cease and desist by any chance by Cylance?
So like, no,
No, so you weren't
And-
asked to stop at all?
we weren't, no, there was no kind of legal interaction between us and Cylance. Again, what we did was 100% legal interaction, 100%. Maybe they checked and they realized that's the case, and that's why they didn't do it. But I think, like, at least the fact that we came with a very powerful journalist on our side, I think that was really important. Because once this became public news, then, you know, do you want to be that company that sues boutique consultancy in Sydney? I don't know, right? So I think it played, you know, in our favor. Yeah.
So if you're a reverse engineer here, but you're a reverse engineer software just made by like some German or French company, which laws take place.
Definitely a question for a lawyer. I don't know.
That's recent.
I honestly don't know. But I think it's, you know, as a layperson, I've read the Scranton law. Again, just as a layperson, don't take this is not legal advice, right? But it focuses on protecting people from competitors trying to steal their secrets, and not from security researchers wanting to, at the end of the day, improve the security of the product.
Just how long did the research, like, so from like deciding when to tech their science product
Yeah.
to getting out the
Research.
yeah, the research, well, I guess more like international like recognition.
Mhm.
How long was that time period?
So the funny thing is, the technical part took about 30 hours of work. All right?
Something awesome project.
The what?
So our security course has a part called a something awesome project where you have the recommended time is 30 hours to work on anything you want.
So
So that was the technical part,
Yeah.
right? Writing the blog post. Oh my God. That was-
This proves our point even more with
Now, you know, talking to the journalist and stuff, and she's a serious journalist, so there was a real process, right? She didn't just take our word for it. She brought in a few experts, they checked our stuff, they said it's complete trash. Seriously, like I said, oh, it's not interesting, they just bypassed security control. They were like, look at the actual method, like, look. It took a few phases that, oh, this is actually really impressive, but it took a few weeks for us to get that, you know, validation from peers. And then it went live, and once it headlined by started really good.
Do you think there's any, like, is there anything that like Cylance could have done differently when they were building their model to make it sort of more impervious to the kind of attacks that you were doing? Or was it sort of
Yeah, definitely. They could have done a few things. So, like, it's gonna sound very trivial, right? But one of the first things they should have done is hire people like us. Like, you wanna be your own worst enemy of your own ideas about security. You want to test what you're doing. I mean, what is this designed to do? Stop hackers, right? So wouldn't it be a great idea to throw tons of hackers at us and make sure that they can bypass, or at least it's very hard for them to bypass that. So that's one. The second thing where I think they missed, their approach was very AI, like pure AI, right? And once you're doing that, I mean, endpoint protection has been around for tens of years, 30 years or even more. There's lots of accumulated knowledge that they just threw down the drain. So if I was them, I probably would mix a few different mechanisms, like the legacy mechanisms, along with AI as an additional layer of security, not just throw everything down the drain and say, oh, done, solved AI. Yep.
This machine learning malware detectors will actually detect the behavioral malware.
If there's product will detect behavior based,
Yeah,
so I haven't seen any behavior based
products
stuff at all.
not
And then,
behavior.
not that I've seen. I mean, there are other products that do this. Legacy products do that, right? If you look at, Symantec, Kaspersky, they all have models that look at your behavior. They sometimes, which for example, look at the type of functions you call and what's the time difference between you call this function and that function. They have all kinds of these behavioral signatures. But no, these guys were just like AI, it's done. Drop the mic. Yeah.
So was Cylance just doing like purely static analysis of programs?
As far as we can tell this. And by the way, there's another huge flaw in their thinking in my mind, because, for example, when we do the black box red team exercise in our company, most of the time we don't even use anything that's malicious. We just leave off the land, we use existing tools, no tools, like things that are good or have a dual use, I would say. So in many modern attacks, just don't use malware. Malware is kind of like 2015, which is probably when they conceive like the based ideas of the company. What else? Yeah.
So what was special about Rocket League compared to other games?
So actually we tried with a couple more games and it also worked.
Yeah.
I think it wasn't as effective as Rocket League, or at least was like had this special bias, but Fortnite definitely worked. 100%. But it was funny because like other benign software, it didn't work. So we tried, for example, Chrome. But I think games, again, they have lots of strings which you will never find in malware, whereas other, let's say productivity software, things like that, you may actually find those strings also in malware. But games, like I said, it's very, very unique. Well, there's a huge difference between that and malware.
Out of curiosity, did you potentially try your method, like your universal passive bypass method, on other products?
No. I mean, it would need to have that string bias work, which I don't know if they have. Could we probably bypass, find other bypasses like AI bypasses for other products? Very likely. But we actually have a day job. Like I said, this is one of the problems that we got annoyed by their marketing, and we said, settle it. No one pays us for that.
Yes.
You had a question before.
Yeah.
It's been answered.
Does machine learning automated tools will work on the detected tools will work like based on the new malwares or new vulnerability scripts exploits based on that? How it will work like machine learning?
The machine learning?
Yeah.
So they have specific, it's actually a very good question, right? Because they came up with this and they're like, okay, done. But then reality hits and they find PowerShell scripts and all kinds of problems like that. So they started adding these smaller features for scripts and things like that. We haven't researched those, to be honest, because again, we could do it with it's skippable. But I think again, that's reality. You throw down the drain everything that was developed in the last 30 years, you're going to have to reinvent it at some point, right? But to be honest, they don't care. They sold Cylance for 1.4 billion, I think, BlackBerry. So.
Like based on
So who's laughing now, right? Anyone else? Yes.
Is Skylight purely an offensive consultancy, or do you guys do like incident response as well?
We do incident response as well. So actually, we're not. I know it's gonna sound weird, but red teaming is not kind of our main thing, to be honest. We do. It's gonna sound a bit more corporate. but we do cyber transformation projects usually. We go to large corporations, we understand kind of what's their security posture, how bad is their state. We help them understand where they need to be in terms of what's, what type of threats are public facing. And then we take them through the whole years of journey. So, and we do also incident response if we have obviously some incidents and something they actually do.
So Skylight's more of a governance and policy consulting firm?
God, no.
Because
No.
I work for that.
Look,
No.
they're basically, I mean, it's not that it's not important, right? But that is, to me, the easier part, usually. So it's not that hard to write a policy document. I've never seen a policy document stop an attacker in my entire life. Right now. But we take a very data-driven approach. So we don't do the, here's a policy. I mean, you need that, so we'll give you that, but that's not what we do. We do a kind of more of a bottom-up analysis. We simulate attackers, we understand the organization, understand what can happen to you as a result of an attack. Focus on that, and we'll make sure we protect those critical assets, etc., from real-world attacks. Now, the other drivers of security, there's the risk. This is risk management, right? We focus not mostly on the actual risk management itself. Some organizations need security as an enabler themselves. They want to have more customers. They have to have certain certifications, and they have to show processes and stuff. That's another aspect which we don't really focus on. We help sometimes, we don't focus on that. And then there's regulation, which is, again, we can help. That's not our focus.
Yes. So for university students,
Yes.
are there any parts of computer science that you found particularly useful for your day-to-day job? Or like particular topics and things like that, or subjects?
Besides linear algebra. Yeah. I think that, like, if you're talking about security, anything that's related to operating systems, networking, definitely, and low-level programming, I would say. So the first are more theoretical in a way. Well, not only theoretical, but it's understanding operating systems, understanding of networking, and then low-level programming, I think, is really helpful. It depends on what, what's your career path, right? What do you want to be when you grow up? Do you want to be a researcher? Do you want to be a red teamer? Do you want to be a consultant? Do you want to be a security engineer? It's different skill sets. But I think that is these things are really strong work basis, no matter what you do.
Actually, this more if you could go back to the past, like let's just say like you're a student now,
Mhm.
what kind of like concept would you really want to study?
What concept?
Or more like let's just say like what course would you like? Would you like to focus more on network or like networks?
For me personally,
Yeah.
networking, I think. But it's just because I'm old.
Yes.
I'm not saying that. When I was a student, networking wasn't that advanced. Like the world wasn't that connected. We couldn't get our courses on YouTube, or we couldn't learn online. So I was more into development that piece, because like it was more about you develop a piece of software, you install it on lots of computers. But networking is something I learned actually later on in my career. That's something that I think could help me more.
Yeah. So another question is, so I know you had to have like some kind of knowledge of AI. Did you have a bit of a background in AI in order to like try that, or did you sort of learn it when you got annoyed with their marketing strategy and then wanted to hack them?
So I did a course on AI when I was in uni, right? So AI, I mean, a lot of people think AI is very new. Like concepts and the theory, not new at all. I learned this in uni, right? All of this, like neural networks, chilling, all that stuff. I did one course, right? Not really focused on that, didn't do anything beyond that. So I remember the terms, but to be honest, most of these things, we just Google along the way.
Yes.
Information is out there, you just need to focus. It's all available. Anything else? Cool. Yeah.
The most common algorithms, machine learning algorithms they use for taking tools.
Oh, I have no idea. Like I said, I'm not an AI expert. I have no idea. Like we literally ad hoc learned what we had to learn for this specific research. We did the 30 hours of the whole thing. How do you call that project?
Something awesome.
Something awesome. We did have something awesome.
Yeah. And we have to write blog posts and things as well. So this is like.
Way longer. Way longer. All right. Oh, yep.
If not, do you have any cool war stories from your time in Israel?
Who said it was defense?
Oh.
It's an offensive subject. I don't know. Can I tell you?
Would you like me to?
What do you want to know?
Or is there anything cool that can be said which is strictly
Would you like me to stop the recording first?
Look, I can't always say I can't tell like things with people. You can ask me generic questions if you want about what does offensive cybersecurity entail and what are efficiencies to identify that, generally speaking, in cybersecurity, those kind of things. I can't get into specific activities, obviously, but you can try some here. He was 7 years at ASD.
Ooh.
He won't tell you either. We have tons of internal jokes about that. No, but I mean, generally, I can, if you want, I can answer. Like, generally speaking, the problems we see in defense, like what failures we see, but obviously not specifics. We have to get it right.
I think it's a more generic question.
All right.
What is the most common failure security that you see? Like whether it's like
I just gave you this question.
more like
What is the common-
is it
most common-
bad password? What is it?
Yeah, I mean, there is, it's a cliche, right? But the human element. So it's really hard. And by the way, there's a big difference between more modern companies, because we work sometimes with startups that need our help to build a security stack. And I think with technology, up to date, it's way better. But when we, for example, work with companies that say that have 2,000 employees, all right? 30, 40 years been in the market, have tons of legacy software, and lots of people have been around before security was a thing. There will always be failures related to that. Someone will always use this password, summer 2021. Always welcome 123 bank. All right, the name of the company, the year, always. I mean, no matter how much awareness training is done, it will have multi-factor authentication, but for some reason it will not be enabled for a third of the company. It's those, the lack of consistency and hygiene, the basic hygiene of security. That's, I think, where most companies fail. And we have a customer in Germany now, Malware. All right, and it's just beautiful to see how security works when there's order and everything is just clean. And I think that's the way. Hygiene. Yep.
Why did you come to Australia to do cyber stuff? Like, why Australia compared to anywhere else?
So I'm an engineer. My wife is an engineer. We have 3 kids that are getting older, and we're like, if we want an international experience, we have to go somewhere else. It's now, and we were just had stable, English speaking, good weather, like the culture, etc. And it's funny, we studied Australia, although we've never been to Australia. So I actually had I was a permanent resident of Australia before studying fully in Australia. Go figure, right? But not a fan of the US culture for kids, to be honest. Not a fan of the Canadian weather or the English weather, so Australia. And I like it.
A good choice.
Yeah, I think so. I mean, you want to hear something funny? Like, I assume you have a certain perception of Israel as a dangerous place. It isn't that dangerous. But when I told people I'm going to Australia, the first reaction of everyone in Israel was like, Australia? Isn't that dangerous? Because we keep getting those National Geographic, 70 worst animals in Australia. Something like that.
Yes, for everything.
I was sure I'm going to get, stung by a spider and die in like 30 days. I was absolutely sure. All right. Thank you, everyone. Thank you for listening.
Thank you. Okay, cool. Thank you. I'll stop the recording now.